Alrighty, this is activity 3.5. Let's get started. Aaron wants to buy new football pads that cost $55 at goodsportsbuys.com. The online store charges $11 for shipping on orders less than $75. He also wants to buy some packages of eye black strips for $4 each, but he does not want to pay more than $11 for the shipping fee. So Aaron is purchasing sports equipment, and I've added pictures for your reference. Take about 30 seconds on your own, annotating that description, underlining and highlighting the important information. But only 30 seconds. This doesn't take long. Pause here. And here are my annotations. Let's read number 1. Write and solve an inequality that describes the possible number of packages of eye black strips Aaron can purchase and still remain in the $11 shipping fee category. Let P represent the number of packages of eye black strips. Explain your solution in terms of the problem situation. So we're being asked to do a couple of things here. We're asked to write and solve an inequality, not an equation, an inequality. If you break that word down, what does it sound like? Kind of sounds like unequal or unequal, and that's exactly what that means. It means that one side of the inequality is either greater or less than the other side. It's also important to note that he wants to remain in the $11 shipping fee category, which means his order has to be less than $75. And P is going to be the variable we use to represent the eye black strips. So let's go ahead and write this inequality based off of what we know. If you're confident and you feel like you can do this on your own, you can go ahead and work on your own as I'm talking. Alrighty, getting started. So we know that his order has to be less than $75. So $75, his order, which is going to go on this side of the inequality, has to be less than that. So how would we write that? I made a quick change to my work. I need to write this in the order that it's given to me. So his order is less than $75. Now let's think about what is in his order. So in his order, he's got football pads for $55, plus he's got packs of eye black strips that cost $4 each. Now I want you to take a second to think, what sign would I use to show that his order is less than $75? Your sign should look like this, where the smaller end of that sign is facing the smaller quantity. So being that his order is smaller than 75, 75 is the greater number, that sign opens up to the 75. And there is our inequality. Now we are to solve. What I want you to do, get these notes down, take about 2 minutes on your own or with the partner, and I want you to solve for P just as you would solve a 2-step equation. Once the timer goes off, we will compare answers. Set a 2-minute timer. Pause here. Alrighty, your 2 minutes is up. When looking at my work, I want you to notice how I solved this 2-step inequality. I solved it using the same steps as I would solving a 2-step equation. The only difference is my sign is a less than sign. Also notice in this problem here that my sign did not change. It stayed a less than sign all the way to the end, where I got P is less than 5, meaning he can buy no more than 5 packs. The packs that the number of packs that he buys, has to be less than 5 in order to stay under that $11 shipping fee. Take about 30 seconds and get this work down if you don't have it. Pause here if needed. Moving on to question 2. You just solved a problem that involves setting up and solving a two-step inequality. Let's compare and contrast the strategies and solutions of an equation and inequality that are similar in structure. Describe the steps you would take to solve the equation 3x minus 2 is equal to 7. Then solve the problem. An equation like this you should be able to do on your own by now. So I want you to complete it on your own or with a partner. This question is twofold, so make sure that you describe your steps and show your work for solving. We will compare answers in about 3 minutes. Pause here. Alrighty, let's compare answers. I described my steps. The first step was I added 2 to both sides, and the second step was to divide both sides by 3, getting you x is equal to 3. If you are also able to get this work on your paper, go ahead and give yourself a big smiley face. Alrighty, question number 3. It says a set of possible solutions for each inequality is shown. Circle the solutions that make the inequality true, then list 3 additional solutions to the inequality. This question here is a question that you should be able to do on your own. But I will also help you out to give you a hint. So there are 2 ways you can do this. You can either solve for x just as you would a one-step or two-step equation, or you can substitute those solutions back into the original equation to see if your answer is true. So you are identifying the solutions within that set and also adding 3 more solutions. Set a timer for about 5 minutes to work on this. When we come back, we will compare answers. Pause here. And here is my work. Notice 3A, if you solved using the two-step equation way, then notice it was the same exact setup as question 2. My answer is just now x is greater than 3. Greater or equal to positive 3. And your 3 additional solutions can be any number greater or equal to 3. For B, those are my circled solutions. And I also, in red, gave you an example of what it means to not be a solution. So if I plugged in a 2 into that equation, that would give me 6 is greater or equal to 9. And is that true? No, that is not true. So that is not a solution. And for C, x just had to be greater or equal to 3. Take a second to get those solutions circled if you haven't already, because we're going to be moving on to question 4. 4 says, what do you notice about the solutions you circled in question 3? What do you notice about the 3 additional solutions you wrote for each inequality? And 6, compare the sequence of the 3 inequalities to the steps you used to solve the equation in question 2. What do you notice? Explain your reasoning. Set a timer for about 2 minutes to answer these questions independently. So your teacher should see your thinking in your answer. 2 minutes to answer question 4, 5, and 6. Pause here. And here are my answers. If you notice different things, that is totally okay. For number 4, I just noticed that all the solutions were the same. For number 5, I noticed that my additional solutions were all greater than 3. And for 6, I noticed that two-step equations and inequalities can be solved the same way. But I have an additional question for you. How many solutions does an equation have? And how many solutions does an inequality have? Take a couple seconds just to think about that. Please excuse my handwriting, but an equation has only one solution, and inequalities can have many solutions. That is one key difference between the two. Alrighty, moving on. Question 7 says graph the solution set for 3x minus 2 is greater than or equal to 7. Now we know the solution is x is greater than or less, greater than or equal to 3 from the previous problem. But this is how you will graph it on a number line. So if our solution is x is greater than or equal to 3, I'm going to start at 3. And being that 3 is included in the solution because of that or equal to, I'm going to place a closed circle on 3. And then I'm going to look, well, which direction are my numbers greater than 3? Well, in the positive direction. So I'm going to then draw an arrow on my line in the positive direction. And that's how you would graph that solution. Now, what do you think would happen if I just had a regular greater or less than or greater than sign without the or equal to? Well, that would then give you an open circle on that number line to show that that solution is not included. Only the numbers that are greater or less than. Alrighty, moving forward, you can check your solution to an inequality by choosing a value that is in your solution set and substituting it into the original inequality. If that substituted value makes the inequality true, then you have verified a correct solution. Number 8 says choose a value from the solution set of the inequality. 3x minus 2 is greater than or equal to 7 and verify that it is a solution. So you're choosing a number from the solution set and substituting. Go ahead and take about 1 to 2 minutes to do this on your own. Pause here. You could have chose any number to verify your solution. I simply chose 4 as an example. And as you can see, 3 times 4 gave us 12. Take away 2 gives us 10. Is greater than or equal to 7. And is that true? Yes, that is true. And we are moving on. Question 9, it says analyze the solution strategy and solution for each inequality. So here you have Ella's work and you have Jeff's work. You're going to describe the strategy that Ella used correctly from a previous activity that we've done. And then you're going to identify the error in Jeff's strategy and determine the correct solution. Now, while you're analyzing, I want you to pay attention to the numbers. Are they correct? Are they not correct? And also the signs that they use. What do you notice is the same about their work? What do you notice is different? Set a timer for about 3 minutes, analyze their work, and answer this question. Pause here. And here's what you should have noticed. Ella used the multiplication property of equality by multiplying both sides of that sign times a negative 4. She wanted to get rid of those fractions and turn them into whole numbers. And Jeff used the division property of equality by simplifying those numbers by dividing both sides of the sign by a negative 4. So they essentially did the same operation or the same thing with the numbers. However, what I wanted you to notice as well is the signs here. So notice Ella, when she multiplied both sides times a negative 4, her signs changed. And when Jeff divided by a negative 4, his signs stayed the same. So what do you think that tells us? Well, from this, we can conclude, and this is an important key point, so you might want to write this down. When dividing or multiplying by a negative number, our sign flips. So your inequality sign reverses from a greater than to a less than, from a less than to a greater than. Anytime you're multiplying or dividing by a negative number on both sides of the sign. Take about 15 seconds to get that down. Pause here if needed. And here we are at the practice to sum up this activity. It says, solve each inequality or equation and show your work. Then graph the solution set on a number line. So for this practice, you're solving and you're graphing. Be sure to show all of your work. For this practice, set a timer for about 15 to 20 minutes. If you're in my class specifically, set a timer for 15 minutes, and you can choose which problems you want to focus on. Alrighty, 15 to 20 minutes, pause here. Alrighty, and here is my work for A, B, and C. I paused here because I started to run out of room, but for 10A, you should have gotten X is less than negative 12, and when graphing, you've got an open circle on the negative 12, and your numbers are less than, so your arrow is pointing to the negative side. For B, you got 12 is greater than or equal to X. And notice how when I divided both sides by a negative 8, my sign reversed. So it was a less than sign. Now it is greater than or equal to. And being that that 12 is included because of that equal to underneath, it is a closed circle. And my numbers are less than that. And I notice I just made a mistake. So let me fix that. All right, now it is correct. And for C, I used a strategy from a previous activity by multiplying all terms by 10 to give me whole numbers. So I got 65x minus 11 is greater than 69, and x ends up being greater than 1 and 3/13. And on my graph, I just showed that 1 and 3/13 is somewhere in between 1 and 2 with an open circle. And my x's are greater, so it's going in the positive direction. If you need to take a second to get some of these notes, pause here. And here's my work for D and E. For D, I simplified that fraction by multiplying both sides of the equation, inequality by 5. That gave me 50 is less than 2x minus 3. I solved using my 2 steps and got 26.5 is less than x. And on my graph, I included an open circle because it is not less than or equal to, so that solution is not included. And then my numbers are greater than that, so the numbers or the arrow points to the positive side. The number is greater than 26.5. For E, I did the same thing, inverse operations. I subtracted 7, and then I'm left with a negative x. But our goal is not to get a negative x. Our goal is always to get a positive variable. So I then had to divide both sides by a negative 1, which then also, remember, flips our sign. So it came from a greater than or equal to now a less than or equal to. So 11 is less than or equal to x, and being that 11 is less than those numbers, on our graph, 11 is included and our numbers are greater than 11. So the arrow is pointing in the positive direction. Alrighty, and this concludes the learning for this activity. You did an awesome job. That was a lot of hard work. Go ahead and pat yourself on the back. Go ahead and high five a neighbor because you made it. I will see you in the next lesson.